Alright, so this video is an extension of right triangle trigonometry. You should know what sine, cosine, and tangent are, and you'll notice the title at the top says 6 trig functions. So this video introduces the, as I like to call them, the evil twin brothers, sisters, redheaded step-cousin, whatever you want to say. These are what we call the inverse trig functions, okay? So we all know our usual sine, cosine, and tangent, but there's 3 other trig functions that we also use in trigonometry. And so we're not going to get into much as why there are 3 others. It's more or less how do you find them and how do you use them within right triangles, all right? But just like all trigonometry, we have to pick an angle to do our trigonometry from, so I'm going to pick angle A. And then I'm going to label all my sides, opposite, adjacent, hypotenuse, based on angle A. So 12 is the opposite, 13 is the hypotenuse, and 5 is the adjacent. By the way, Pythagorean triple, fun fact. All right, so sine of angle A is 12 over 13, because, as of course we know, we have our fantastic phrase that we like to say, so ka toa, and it tells me which trigonometric function is sine, cosine, and tangent. It also helps remind me which function goes with which side. So sine is opposite over hypotenuse, so S-O-H. Okay? And that means cosine is going to be 5 over 13 in this triangle, because cosine is adjacent over hypotenuse. And then tangent is 12 over 5. So 12 over 5 is tangent because opposite over adjacent. All right? So, and again, sin, cos, and tan, those are just the abbreviations we use, because sine, cosine, tangent, those are the full words that we use. But on the calculators that you use, you'll notice it says sin, cos, and tan. And those are trigonometric functions. All right. And sometimes you may have to be dealing with the inverse functions of sine, cosine, and tangent. Okay? Which you might be saying, well, wait, I already know that. Don't we use it to find angles in a triangle? Sort of. So the reciprocals would be another word you can say. The reciprocal of a sine function is actually called cosecant, and we abbreviate CSC. All right? So cosecant is the inverse or the reciprocal of sine. And when I say the word reciprocal, perhaps you know what that means. Doesn't that mean I flip fractions? So if I know sine of angle A is 12 over 13, that means cosecant of A is 13 over 12. And again, remember, sine and cosecant are inverses of each other. So if you know one of those, you'll know the other one. So if you know that cosecant is 13 over 12, you know sine is 12 over 13. So they go together. All right? And now let's take a look here. So sine didn't have a co in front of it, but notice how it's reciprocal. We put a co in front of it, so cosecant. So notice how cosine already has a co in front of it, so its reciprocal won't. So the reciprocal of cosine is secant, and we abbreviate it SEC. So the reciprocal or inverse of cosine is secant. And the secant of A, again, just like cosecant wants to sine, the reciprocal of cosine, so instead of 5 over 13, it's 13 over 5. And remember, cosine and secant are inverses of each other. They go together. Okay? And then, like sine, remember how we added co to it for its reciprocal? So tangent, the reciprocal identity to tangent is cotangent, which we abbreviate as cot. C-O-T. And if tangent of A is 12 over 5, cotangent of A is going to be 5 over 12. Okay? And tangent and cotangent go together. All right, so that is the reciprocal identities there. And we use all 6 of these. And basically, with right triangle trigonometry, not as crucial to know those, but you'll see why as we progress in our mathematical careers. Secant, cosecant, and cotangent, they have their uses in when we graph trigonometric functions, which again we'll get into another time. But it's helpful just to know that sine, cosine, and tangent have other functions that go with them, and they're essentially the reciprocals and the inverses. So if I ask you to find all the trig functions from angle B, and then we just have to relabel real quick, so that 12 is the adjacent and 5 is the opposite. Okay, so if I ask you to find all of the trig functions, all 6, of angle B, what would you do? So pause the video if you want to test yourself, but I'm going to go ahead and keep going here real fast. So sine of B will be 5 over 13. Cosine, adjacent over hypotenuse, would be 12 over 13. Tangent of B is opposite over adjacent, which is 5 over 12. Cosecant, or CSC of B, is hypotenuse over opposite, which is 13 over 5. Secant is hypotenuse over adjacent, which is 13 over 12. And then cotangent of angle B is adjacent over opposite, which is 12 over 5. All right? So that is kind of the basics and the rundown of it. Obviously, it can get a little bit more complicated, but this is the introduction video to the 6 trig functions.